Welcome to today's video, section 4.4, trigonometric functions of any angle. In the last section, we evaluated trigonometric functions of just acute angles in right triangles. Today, we're going to talk about how to evaluate an angle in standard position that is not an acute angle, that maybe is rotated more than 90 degrees. So any angle. This angle theta here is more than 90 degrees. To do that, we always pick a point on the terminal side of the angle and we call it P. And notice P has an X and Y coordinate that go along with it. We also talk about the distance from P to the origin because that's the measure of this side here, and that is what's called R, because R is the distance from P to the origin. Remember, in the origin 0, 0. Now, in order to find the trigonometric ratios, what we do is we create what's called a reference angle, which is right here. And the reference angle is defined as the angle between the terminal side and the x-axis. So notice, I rotate this angle here. There's a little reference angle created right here between the angle and the x-axis. This is my reference angle. Now, based upon that reference angle, we can actually make a right triangle by dropping an altitude here. Now, what that does is that creates some values for us. For example, let me use the red one. From here to there, that is actually the value of whatever x would be for a point P. And from here to here, that would be the y value. And then we have our r value here. Now, using this triangle created, we can come up with the 6 trigonometric ratios for this angle theta based upon the reference angle. So let's look at this picture here. Now, basically, if we have this picture, notice the sine of theta, or this reference angle here. Remember, it's opposite over hypotenuse. So here we have x over r. Actually, sorry, I did this backwards. It should be x here, y there. So it's y over r because it's opposite over hypotenuse. The cosine is x over r because it's adjacent over hypotenuse. And the tangent is y over x because it's opposite over adjacent. Then the cosecant is the reciprocal, so it's r over y. The secant is r over x, and the cotangent is x over y. Those are the 6 trigonometric functions of any angle. So basically, to find them, I need to basically draw a right triangle using the reference angle. So let's do an example. So let's say I have this problem here. It says let P equal -3, -5. So I'll draw P, and I'll go all the way to the third quadrant. You might ask, well, why did I go all the way to the third quadrant? Well, -3 and -5, x and y are both negative in the third quadrant. So that's why -3, -5 would go there. So basically, when I draw a right triangle, I'm going to use, remember, I use the space between the terminal side and the x-axis. Y is -5, x is -3, and then I want to find out what r is. And remember, r, we can get by doing the Pythagorean theorem. It's the square root of -3 squared plus -5 squared. So it's 9 plus 25, which is 34. So r is the square root of 34. So based upon that, I can find my 6 trigonometric ratios. Because remember, cosine is x over r, so it's negative 3 over the square root of 34. And remember that rationalizes to the negative 3 square root 34 over 34. The sine, remember that's y over r, so that's negative 5 over the square root of 34, and that rationalizes to negative 5 square root 34 over 34. Because remember, rationalizing, you multiply the top and bottom by the square root. The tangent, that's y over x, so that's negative 5 over negative 3, which reduces, actually doesn't reduce, but simplifies, because negative over negative makes it positive 5/3. Then it will be easy for me to find the other ratios, because the secant, remember, is the reciprocal of the cosine. Well, the reciprocal of the cosine would be the square root of 34 over negative 3. The cosecant is the reciprocal of the sine, and that would be the square root of 34 over negative 5. And the cotangent is the reciprocal of the tangent, and that would be 3/5. And that is how I would do that type of problem. Go ahead and try this one on your own. We're going to skip it for now and go to the next topic, which is trigonometric functions of quadrantal angles. Well, remember, any angle that is not in a quadrant is what's called a quadrantal angle. And so basically, if we want to find trig functions of quadrantal angles, for example, 0 degrees, notice we can't draw a right triangle. Right? It's impossible for us to draw a right triangle here. So we have to come up with a different way. And that's why we use these values of x over r and y over r. So for example here, I could pick any point on the x-axis here for 0 degrees. Like I could pick 4, 0, because remember 0 is on the positive x-axis. It makes sense just to choose 1, 0, because 1 is an easy number. So remember, this is my x and this is my y. So if I'm trying to find the sine of 0 degrees, remember sine is y over r. Well, y is 0 here. And what is r? Well, r, remember, is the square root of x squared plus y squared. Since x is 0, or sorry, since x is 1, 1 squared plus 0 squared. So basically it's the square root of 1, which is 1. So 0 over 1 is just 0. So the sine of 0 degree angle is 0. If I wanted to find the cosine of a 0 degree angle, remember that's x over r, and the x value is 1. The y value, r value is 1. So 1 over 1 is 1. The tangent of 0, remember that's y over x. So that's 0 over 1, which is 0. And as I go along here, like here, I would use the point 0 for x, 1 for y. If I was 180, I would use negative 1 for x, 0 for y. And if I was at 270, I'd use 0, negative 1. It's just much easier to deal with the number 1 than using 0, 5 or 0, negative 5. For 270 degrees, if I wanted to find the sine of 270, or 3 pi over 2 in radians, well, remember sine is y over r. So I'd go negative 1 over, and remember it's still going to be 1 for r, so it's negative 1. Cosine, 3 pi over 2 would give me x over r, which gives me 0 over 1, which is 0. Tangent 3 pi over 2 gives me y over x, and remember y is negative 1, x is 0. Now if 0 is on the bottom of the fraction, remember that's undefined. And that is a possibility when you're doing trig functions, is that it could be undefined, especially tangent. Tangent is one of those, and cotangent. Now, it helps to know the signs of the trigonometric functions, like whether they are positive. So let's look at the coordinate plane again and ask ourselves, what quadrant is x positive? Well, remember, x and y are both positive in the first quadrant. X is negative, y is positive in the first and second quadrant. They're both negative in the third, and x is positive and y is negative in the fourth. That's what we're talking about, x, y. So x is positive in the first and the fourth. Y is positive in the second and the first. R is always positive because remember, you're going square root of x squared plus y squared. So you're squaring stuff and taking square root, so R is always going to be positive. The reason it's important is because if you notice, remember we talk about cosine equaling x over r. So what this basically means is that in the first and fourth quadrants, cosine is positive, right? When we talk about sine, sine is y over r. So this means in the second and first quadrants, sine is positive. And then tangent is y over x. And notice now y over x, that means in order for it to be positive, you have to have the same signs. Like the first quadrant, positive over positive gives me positive. Positive over negative does not give me positive in the second. Negative over negative does give me positive in the third. And in the fourth, it would not be. So if you look in the first quadrant, sine, cosine, tangent are all positive. So notice they're all positive in the first quadrant. In the second quadrant, notice the only one that's positive is the sine. In the third quadrant, the only one that's positive is the tangent. And the fourth quadrant, the only one that's positive is the cosine. And a way to remember this is to say that all students take calculus. All trig functions, sine, cosine, tangent, are positive in the first quadrant. The sine is positive in the second. That's where the students take. It means tangent's positive in the third quadrant. And calculus, cosine's positive in the fourth quadrant. How does this help us? Well, it helps us for this problem here. It says if tangent of theta is less than 0 means negative, and cosine is greater than 0, meaning positive, name the quadrant which the angle lies. We'll go up here and think about it. If tangent is negative and cosine is positive, well, first of all, cosine is only positive. Cosine's positive in the first and fourth quadrant. Tangent is positive in the first and third, which means it's negative in the second and fourth. So think about, where do they overlap? It overlaps in the fourth quadrant. So this angle has to be in the fourth quadrant. If sine of theta is less than 0, which means negative, and cosine is less than 0 is negative, name the quadrant which the angle lies. Well, remember, all students take calculus. So basically, the cosine is positive in the first and the fourth, which means it's negative in the second and third. And the sine is positive in the first and second, which means it's negative in the third and the fourth, and you look to where they overlap and notice they're both negative in the third quadrant, which means that's where the angle lies. So then you can also use this to help you solve problems. So it says the tangent is negative 1/3. So notice the tangent is negative in the second and fourth quadrants. It says the cosine is less than 0, which means negative. So basically, we need to know where is the cosine negative. The cosine's negative in the second and in the third quadrant. Well, where does it overlap with the tangent being negative? The second quadrant. So we know our picture that we draw here has to be in the second quadrant. So this is theta right here. Now remember, we use the reference angle to draw a right triangle. And remember, tangent's y over x. So I know that my y value is 1. Sorry. My y value is 1. And my x value is 3. And x is negative on this side, so that's why it's a negative 3 and not a negative 1, because 1 is positive in the second quadrant, the y value. So now you need to find r. And remember, r is the square root of x squared plus y squared. So r is equal to 1 squared plus negative 3 squared. So it's equal to 1 plus 9, which is the square root of 10. Now the question says find the sine of theta and the secant of theta. Well, remember, sine is y over r, which is 1 over the square root of 10, which is equal to the square root of 10 over 10. The secant, remember, that's the reciprocal of the cosine. So if I did cosine, it'd be negative 3 over the square root of 10, but remember, it's the reciprocal, so it's the square root of 10 over negative 3. And those are your two answers. Hope you've enjoyed this video. It's a lot of stuff, and we'll go over it tomorrow. Have a good evening. Bye.